Okay, I'm going to work a couple of nonlinear systems of equations. I'm going to illustrate in the first one, use a substitution method. So I have two equations, which I'm going to write down as a system. I have x squared minus 4y squared equals 16, and 2y minus x equals 2. If I try to just add these two equations together to eliminate a variable, I could not do that. So I am going to choose a variable that has a coefficient of 1 and has no squares on it. So my choice is right here. I will take this bottom equation and I will solve it for x. So I am going to subtract the 2y. So I've got negative x equals negative 2y plus 2 that's already there. To solve that for x, I divide through by negative 1, getting positive x equals 2y minus 2. Enclose that in the parentheses, and I will substitute that expression into the other equation in place of x. So this x right up here will become 2y minus 2. So I've got 2y minus 2 squared, and write the rest of the equation down. And now I have one equation and one variable only, and that variable is y. 2y minus 2, the whole thing squared would be 2y times 2y, that is 4y squared. And then I'm going to have a minus 4y in the middle, and another minus 4y, and then a positive 4. And then I have this last term over here, minus 4y squared equals 16. Now my minus 4y and positive 4y squares add to 0. So I would add minus 4y to get negative 8y plus 4 equals 16. Since I don't have any squares, I don't have to set the equation to 0. I will just move my positive 4 to the right. I have minus 8y equals 16 minus 4, or 12. So y equals negative 12/8, which reduces down to, divide by 4, I get negative 3/2. Now to find the x that goes with that particular y, because remember I'm looking for ordered pairs in the end, I go back up to where I have solved for x, and we'll circle it right here in red or purple. I will put my y value of negative 3/2 into that y to find the x that goes with it. So I have x equals 2 times negative 3/2 minus 2. X equals negative 3 minus 2, or negative 5. So my actual answer would be, as an ordered pair, negative 5, negative 3/2. And I used a substitution method to solve this nonlinear system. I will solve another problem. In this one, I'm going to use a different method of solution. My problem is, first equation, 3x squared minus 2y squared plus 5 equals 0. Second equation, 2x squared minus y squared plus 2 equals 0. And these two equations are lined up, which means they both have the squared, x squared first, then the y squared, then the number. So I look at these and I see that I can multiply the bottom row by a negative 2, and then I would have a positive 2y squared down here, which would add out with a negative 2y squared above it. So that's what I'm going to do. I'm going to recopy the top row as it is. Then I'm just going to multiply each term in the bottom row by a negative 2. So I have negative 4x squared plus 2y squared minus 4 equals 0. Now you just add both equations together all the way across. Positive 3 and negative 4, I'll get negative 1x squared the 2y squared terms cancel to 0. That's why I did this to begin with. Positive 5 and negative 4 is a plus 1. Now, since I don't have a middle term, I can just move my x squared to the right and get 1 equals x squared. To solve that, I just say x equals the plus or minus square root of 1, which is plus or minus 1. Now, each one of these x values could have one or more y values. So I take the first x value of 1, and I will find the y value by plugging this 1 back into one of the original equations. I'll just put it into the top equation up here. So I've got 3x squared minus 2y squared. 3x squared minus 2y squared plus 5 equals 0. So I've got 1 squared is 1 times, so I've got 3 minus 2y squared plus 5 equals 0. Now I'll have negative 2y squared plus 8 equals 0. I'll move my 8 to the other side, making it negative. Now I'll divide both sides by this negative 2 to isolate the y squared. I finally get y squared equals 4. So y is plus or minus the square root of 4, which is plus or minus 2. So what I found is when x equals positive 1, remember I started by putting a positive 1 in place of x, the two y values are 2 and negative 2. So my answers so far, 1 with 2 and 1 with negative 2. Then I have to go back and use my other value of x, which was negative 1. Remember I had plus or minus 1, so I'll put a negative 1, or I'll let x now be negative 1, the other value for x, and I will find the corresponding y values. I'll use that same equation, 3 times negative 1 squared minus 2y squared plus 5 equals 0. Of course, negative 1 squared is 1. Let's get the same thing I had before. I'm going to move my negative 2y to the right this time. Divide by 2. So again, y equals plus or minus 2 when x is negative 1. So those ordered pairs are negative 1, 2, negative 1, negative 2. So I would have to state all 4 answers for my final solution. So there's 2 up here and 2 down here. Now I do want to call your attention to something that can happen when you're solving these systems. Sometimes there is no real solution. So we'll look at one more example. 2x squared plus y squared equals 2, solved with x squared minus 2y squared plus 8 equals 0. Now these two equations are not lined up because the top one, the constant's on the right, and the bottom one, it's in the equation. So I'm going to move this 8 to the right. So my system looks like 2x squared plus y squared equals 2. 1x squared minus 2y squared equals negative 8. Now I would probably choose elimination method because these are all have squares and they like the two equations match each other. So I see if I multiply the bottom equation by negative 2, my x squares would add to 0. So over here to the right, I'm going to copy the top equation down. But the bottom I'm going to multiply by negative 2, so I'll get negative 2x squared. That will make me have a positive 4y squared equals 16. Make sure you also multiply the constant term. Now when I add these two equations together, of course my x squares are gone, and this 4y squared plus 1y squared, I have 5y squared. I lost my problem. Here we go. 5y squared equals 18. Now we'll divide by 5 and I get y squared equals 18 fifths. y equals plus or minus the square root of 18/5. Okay, so when I substitute this back into the equation to find the x's that go with it, let's note what happens. Let's use the top equation, and it says 2x squared plus y squared. Well, y squared here was 18/5. If I square that, equals 2. Now, I've got 2x squared equals, so when I subtract 18/5 from 2, I am going to get negative 8/5. And you cannot have a squared equal to a negative. You can't have an x squared equal to a negative number, and that indicates no real solutions, because no real number squared will equal a negative value. So this is a case where you can get no real solutions, which means these graphs up here must not have intersected in any point.